Hello everyone, welcome, and today we're going to do a little bit of a demonstration here that I typically would do, only I'm going to have the extended version because it's got more time here than I do in my average class. So what we have here is a problem. The scenario is that someone left in the middle of a job. The job was left uncompleted. The idea was that these three routers were to be connected up. Imagine some type of small business environment where a few minimal workstations were set up and one area needs to connect to another area. We've got three routers in place, so it's a relatively large area. So maybe we are dealing with a kind of medium enterprise, because a small enterprise would just have one router. We have routers B and C, which are already there and already established and work, and we are connecting router A in this 10.0.1 network. Now the scenario doesn't completely make sense. Why would you already have a 10.0.3 and 4 network and then you're going to add a 1 and 2 later on? I don't know. The thing is, routers B and C are already somewhat set up, or at least according to the reports. A is not connected, and that's fairly obvious. We want to get connectivity between PCs 1, or the two PC1s, and PC 2. So the first thing you do in a basic trouble ticket most of the time is you would go in and you would validate the configuration, or at least you'd validate the problem. Now it's fairly obvious physically, we can see there's a line disconnected, but if I try to ping, this is the 10.04, so 10.0.4 network, and we're going to .100 on that. So can we ping 10.04.100? And the answer is no. We cannot ping 10.04.100. Why? It says it's not reachable. Always look at the error message. It says that the host 10.01.254 is not reachable. So if we come over here, we can see that 10.01.254 is router A. And we ping it, and we wouldn't expect any response back because we had the error message that said it wasn't reachable. So with it not reachable, it's not reachable. That means that something is wrong between layer 1, layer 2, and layer 3 between PC1A and router A. Now the reason PC1B is there is to provide a little guidance. Now that doesn't eliminate anything. It just says that there's a problem between PC1A and router A, and it is in layers 1, 2, or 3. Now we can visually inspect layer 1. We can see that it looks like it's happening. We really don't know about that switch and if it's functioning. We could almost rule it out. That's an unmanaged switch. So with that being an unmanaged switch, there's not really much that can go wrong with it. Not much we can do if it does. Place the switch, but yeah, that's not it. What we should do is we should ping PC1B, and we can ping PC1B just fine. That is successful. So that means we have just ruled out a layer 1 problem between PCA and the switch. We've ruled out the layer 2 problem of the switch itself. So that means that we have communications within the same network. Now the one thing I didn't do would be to look at the configuration of PC1, and that's already here. 10.0.1.1 network 24-bit net mask, which fits on this network, and the default gateway of 10.01.254. Through process of elimination, what that leaves us with is the fact that the problem must be at router A. Okay, not must, but most likely at router A. So let's go ahead and check out router A. All right, so I'm here at router A, and this is a Vios router. So I'm going to use the Vios commands. Hopefully my Cisco brain doesn't kick in and I start using Cisco commands. The reason I use Vios is so that it is possible to distribute this GNS3 topology, and because it's all open source. All right, so if I do a show configuration. Now, showing the configuration is one very big way to troubleshoot this. Probably one of the better ways to troubleshoot is sometimes check the configuration. So if we look at the configuration, we can see that 4 interfaces, Ethernet 0.0, or Ethernet 0, Ethernet 1, Ethernet 2, Ethernet 3. These interfaces are unconfigured. The only thing you can see on them is the Ethernet interface. It is the fact that there's a hardware address configured. So the incomplete configuration apparently goes with router A. Now, like I said, from the steps that we gathered, your theory of probable cause after pinging everything is that there must be something wrong with the router. And we come into the router, we check the configuration, we see that it's not configured. Knowing the scenario of what happened, that someone did not finish configuring this and we're going to finish it up, that makes sense. Router A was not configured. It wasn't even connected. So now we have to configure it, and we're going to take a look at the configuration. Now, Ethernet 0 is not connected, and Ethernet 1 is the one that's supposed to connect router A to router B. So let's take a look. I'm going to go into configuration mode. There we go. And in configuration mode, I am going to set the IP address. Now, if you're going for Net Plus, the commands I'm about to enter don't really matter. The thing is what I'm doing. I am setting the IP address on Ethernet 0. Different routers, different operating systems on routers would be different. If this were Cisco, I would go into configuration mode, I would go into interface Ethernet 0, and I would do an IP address command to set the IP address. I'd probably also do a no shutdown, but I don't need to here. But since this is Vios, the command is set interface. And if you're using command line environments and you can use the tab key, use it. Set interfaces for an Ethernet, and we're going to set Ethernet 0, and we're going to set its address to 10.0.1.254/24. So that's going to set that interface. So while we're at it, we might as well set Ethernet 1 to an address of 10.0.2.254. Now, this is the 10.01 network that's out this interface, and this is the 10.02 network down this interface. Now, remember that routers need an IP address for each interface. So when I set these interfaces, then what's going to happen is it's going to take this and it's going to put it into its routing table. So let me go ahead and commit the change. And normally I would save the commit afterwards, but I'm not going to save anything in this lab. I'm going to exit out of it. And then I'm going to do a show interfaces. And I can see that Ethernet 0 and Ethernet 1 are connected. Notice in this one. Now the outputs of these commands are going to vary from manufacturer to manufacturer, from vendor to vendor. So Vios, which uses a system called Vieta to turn a Unix machine into a Linux machine, gives this. So we can see that Ethernet 0, 10.01.254, so Ethernet 0, 10.01.254, and Ethernet 1, which we don't see it saying Ethernet 1 because it's not connected, is 10.02.254/24. And so we're matching, we have the right IP address. So let's take a look at the routing table. Routers work by doing a routing table. So if we do a show IP route, and I have configured Ethernet 0, I've configured Ethernet 0 and Ethernet 1, and we can see there's one entry in the routing table, and that's for the 10.01 network. Because once you configure and enable an interface, it goes, that network is there. I have given it the IP address of 10.01.254. I've given it the network mask of a 24-bit network mask. So anything that matches the first 24 bits of 10.01.254 is out that interface. Now Ethernet 1 isn't online. It's not connected. It's not running. So we don't see it in the routing table. If the interface is down, then obviously that network is not connected anymore. And you can see that Ethernet 1 over here shows as an up-down state. Up meaning it's something physically connected, even though there's not. Routers can be configured to lie on that one. And the down state means that it doesn't detect an Ethernet carrier there. So we have the issue of it being in an up-down state because obviously the cable's not connected. And as a result of that, the configuration I put on it isn't making it into the routing table. So let's go ahead and remedy that. As I connect Ethernet 1 to Ethernet 0. Now, if this were a Cisco router, I would easily have picked up a message that says, hey, it's connected. But like I said, different vendors are going to behave differently. Now, if I do a show IP route, I should see 2 routes in there. So anything that starts with 10.01 is the first 24 bits. And remember, 24 bits is the first 3 octets. You know, /24 is equivalent to 255.255.00. All right, so that would be the first 24 bits. Starts out with 10.02 and 10.01. So we see the 2 directly connected networks. All right, So it might be obvious from looking at the routing table that it's not going to get to the 1004 network, but let's go back to PC1A anyway, and we'll go ahead and ping 10012. We still get pings from 10012. All right, so let's go ahead and ping 1004100. So 1004100 gives an error message, but it's a different error message this time. 1004100 shows destination network unreachable. And we can see that right here. But most importantly, and this is an important thing about using ping for troubleshooting, it's not just a yes or no answer. We're getting a it's not working, and we're getting it's not working at 10:01:254. Remember, ping works by sending out an ICMP echo request, and that echo request packet travels across the network to its destination. If it reaches the destination and the destination feels like answering back, then we're going to get an answer back and it'll come through. However, if something doesn't make it there, a router should send back a message saying what went wrong. Now, sometimes it can't because it doesn't know how, but that's going to be important in troubleshooting. Now, in the real world, rather than this lab, that doesn't always happen. What would normally happen is it would get to a router that would have no route to it, but it would have a default gateway. But router A does not have a default gateway, so it gives us the network unreachable message when trying to get to 1004.100. And the reason is, if we look at the routing table, there's 1001, there's 1002. There's no 1003, there's no 1004, there's no default gateway. It doesn't have a route to host. So let's go ahead and fix that issue. Let's put a route that says to get to the 1004 network, send it to router 3. And let me clean up the diagram here. I'm going to go into configure. Basically, the routing table contains a list of network IDs or network prefixes. And the way it works is it says if anything matches this network prefix. So the way to read this is if the first 24 bits are 1001, then we're going to follow this entry. Now all of them are 1001 entries. So I'm going to go ahead and I'm in configuration mode. I've put in a command that says set a static route for 1004. Anything that starts with the first 24 bits of 1004, send it to 1002.253. And if we look on the network diagram, 1002 is the network between routers A and B, so 1002.253 is Ethernet 0 on router B. Now I could just say send it out the interface Ethernet 0, but it is better to send it to an exact next hop if we can, because that way it can go get the MAC address of 10.02.254 or router B's Ethernet 0 and store that in its ARP table so that it doesn't have to try to figure out where on the 10.02 network the next hop is. So I give it the next hop of 10.02.253. So what that means is to get to network 4, which is over here on the other side of router C, we have to send it through router B. Now this is very important that you understand that all routers are acting independently. That means that each router has to have its own routing table. And when each router has its own routing table, that means it gets to router A, a decision is made, it sends it to router B. Gets to router B, a decision is made, it gets to router C. Gets to router C, a decision is made, it gets to the end device. Gets to the end device, the decision is made is, hey, this is mine, and it sends up the stack. This is the relay race that is IP. So now that we have that, all I have to do is commit this change, and now the packet should get through router A. So you also keep in mind that you must have a path there and a path back. When I go back to PC1A and I ping 10.04.100 again, now I get a sequence timeout. This is what we normally get out of pings that are failing, because most routers out there will have a default gateway and it will always have a route to somewhere. But in this case, what's happening is PC1 sends it to router A. Router A sends it to router B, and it's never heard from again. At least that's what we're assuming. Now, if we wanted to make sure that that was the case, we can run a trace route. Now, the trace route comes up with a result that it gets to the first one, it gets to router A, and then it tries to go to router B, and router B is where it's lost. So we get that it's timing out. Now the timeout means that it's getting there and not back. 9 times out of 10, that means somewhere on the path it's taking a wrong turn or the traffic cannot get back. So router A sends it to router B, and router B doesn't send it back. Now, I know what the problem is, but if you were troubleshooting this, you would probably go to router B, because we see it getting to router A, but we don't see it getting any farther than router A. That could be an issue. That means that router B, the next hop, is the point where it's failing, so that's where you should investigate further. So here I am at router B. Let's take a look at our hypothesis and try to come up with a guess. All right, there are two possible scenarios here. One, router B wasn't configured. Router B's Ethernet 0 wasn't configured. Not a bad hypothesis to make, especially since router A was not configured and the link between A and B was not there. Based on what had happened, a very probable cause would be Ethernet 0. Now, technically, the error would have been a slightly different one if that had been the case, but that's not a bad hypothesis. The other probable cause is that router 2 just doesn't have a route to the host. Doesn't have a route there, and that's another probable cause. Now, we can check these by doing, say, show configuration, and we look at show configuration. We can see Ethernet 0 has an IP address, and it is correct, 10.02.253/24. All right, that looks good. And Ethernet 1 is also configured with an IPv6 address nonetheless, but we're not going to go into that one. It is configured with 10.03.253/24, and it's active, it's up, it's running. So what I should see at the very least is the direct connection to Ethernet 0 and Ethernet 1 in the routing table. When I quit out of the show config and do a show IP route, and that's what I see. I see 10.02, 10.03. We have the direct connections. We don't know how to get to 10.01, and we don't know how to get to 10.04. So only the direct connections are here, and this is the default state of a router. These are the directly connected routes, and we need to put in the learned routes. Put in a route for 10.010/24. Next hop 10.02.254. So looking at it, I'm on this router, I'm on router B. We have to get to 10.02 or to get to the 10.01 network. If the first 24 bits are 10.01, send it to 10.02.254, router A. Might as well, while we're here, go to 10.03.254 if we're going to network 4. So if the IP address starts with 10.04, if the first 24 bits are 10.04, then we're going to send it to router C at 10.03.254, or we're going to send it to 10.03.254. Now we know that's out Ethernet 1 because our routing table says that the 10.03 network is out Ethernet 1. So now I have the configuration. Router A is configured, router B is configured, and we just need to check it out. So back to PC1A, where I'm going to go ahead and do a ping, and we're going to get timeouts still. Doesn't really help much, does it? So, but I do a trace route, and we see we get a little farther this time. So it goes from PC1A, it goes to router A, and then it goes to router B. And then router B can send back a packet because we're getting a message from 10.02.253 from traceroute, and it says that it's getting to router B, but we can't get past that. So we know router B is routing 10.04 to router C, so now that means that we need to take a look at router C. All right, here we are at router C, and we'll just do a show IP route because we know we can tell if the interface is up or not based on the routing table. We know that the 10.03 network, we know that Ethernet 0 is up because the entry is appearing in the routing table. We know that 10.04 is up because the entry is appearing in the routing table. Because if the interface goes down, remember from router A, it doesn't show. So it is up, it is configured, and we have the 10.03 out there, and that's correct, and the 10.04 out there, that's correct. The only other thing I might want to do is verify that 10.03.254 and 10.04.254 are actually there. But we can already see in the routing table that I've got 10.03, I've got 10.04, but I don't have 10.00. All right, so this is where we get to go into what's called the default route. Now, the default route is the route that you take when there's no other route that matches it. That is the route that you take. Now, you take the route to 10.03, 10.04. There is nothing there for 10.01. 10.04 is directly connected, but you have to remember that traffic has to go there and it has to go back. So not only do we need an entry for 1003, or excuse me, for 1004, the destination, we need to be able to send the return packet back, which is 1001, which is why it's failing here. But the default route is the route that it would cause. Let's take a look at router C. Router C is what we call a stub router. A stub router has a link to only one other router. Router C is connected to router B. Now, network 4 is also a stub network because network 4 only goes to router C. There's only one router on there. That's why PC2 has its default gateway set to 10.04.254. That's why PC1A and 1B have their default gateway set to 10.01.254, because those are stub networks. And as stub networks, there's only one way out. Just like router C, if it's not going to one of the two directly connected networks, 10.03 or 10.04, it just needs to go to router B. So the default route is simply the route that if nothing else matches, it's going to take that one. But here's how it works. Now, in the case of all of the routes that I've put in, they've all been 24-bit prefixes. And that means that they're all matching 24 bits, or the first 3 octets. If there were ones that were other matches, then it would have to decide. So say there was another entry in there that said 10.0.00/16. So it would be a 16-bit match. Now, anything going to 10.04 or 100 would match the 10.0.00/16, as well as the 10.0.40/24. It would match both of those. It is both a 16 match of 10.0 and a 24 match of 10.04. So which one does it choose? It chooses longest prefix match, or best match. But longest prefix match is the principle that if I have multiple entries in my routing table that would match, then it's going to take the best match, or the longest prefix length. In other words, a 24-bit match beats a 16-bit match. It's as simple as that. Now, if I have a 0-bit match, that matches everything. If I don't have to match any bits in the IP address in order for it to be a match, then it's always going to be a match. So the default route of 0000/0 is a 0-bit match. Now, if there's any other match in there, like for instance a 24 or a 16 or an 8 or an 18, that would match better than a 0-bit match. So if there's nothing better in the table, a 0-bit match works. So let me put in a default route. All right, so the protocol static route, putting in the entry of 000/0 into the routing table with a next hop of 10.03.253. And that is the default route. And that's simply how you typically put it in. Now, your default gateway on your local machine, if you were to look at the routing table inside Windows or your Mac or Linux, whichever operating system you are, if you were to look at the routing table, if you're on Windows, you type route print at a command prompt. Anywhere else, just usually type route or netstat-r, and you can see the routing table on there. And in there, you will see a route to 0000/0000 as an IP address and network mask. And that would be your default route. And you would see that it is going to your default gateway that you've configured. That's because your end operating systems will configure a default route when you configure a default gateway. Configure that, commit it, and we should be done here. Because now we can go send our packet through router A to router B to router C to PC2. And then PC2 will turn around and send the reply to router C. Router C knows how to get it back. Because it doesn't match any of the directly connected networks, it's going to send it to its default route to router B. Router B already has an entry that says, okay, the 10.01 goes to router A. And router A will send it back to PC1A. So when I do this, and when I go ahead and ping PC4, it works. And so when I ping PC2, when I ping PC2 over on the 4 network, it works. It gets there, it gets back, and we have restored connectivity. We document, we close the ticket, and we walk away thinking job well done. All right, let's go into the bonus round. All right, so router C is a stub router. So it uses a default gateway to get back to router B. Not a problem. Router A is a stub gateway, so it uses, well, we have an entry for that. And if I were to say ping 10.03.254, I'm going to get a network host unreachable from router A. And that's simply because I only put in a route to network 4. I didn't put one into network 3 because I don't really need it. That's a transit network, probably not going to ping anything on there or communicate with those. So the solution here is going to be, I'm going to reconfigure router A. So let me go remove this and set a default route to router B instead of the other way around. So we set that. So now I commit those changes and we can see that I have the default gateway, the all zeros route, heading there. So let's see if the changes I made work. First, we're going to ping 10.04.100 to make sure that we still have the same connectivity we had before, and that hasn't been interrupted. And now I can ping 10.03.254, and we can see that happening as well. So what I've set up is the beginnings of what's called a hub and spoke topology. And that is that router B is the hub. For static routing, I only have to manage and maintain this one router. I don't need to maintain the routing tables on A and C because they're just set with a default gateway or a default route to go back to router B. And then I could do something like connect router B to the internet or to get our way out. Router B being the hub to get out to the network would make sense. Now, in a real world scenario, probably router B would be maybe your edge router or a distribution type router, or maybe even your core switches, and routers A and C would be layer 3 switches. But the fact that they're routers and have routing processes are the big part of this. So with this, I have static routing, and it's configured and is using static routing, so everything's working. We have connectivity between the PC1s and the PC2 over there on the other side. Okay, guys, this has been my routing and troubleshooting demo. Hope you learned something. And, if you want more, like, subscribe, comment, etc.